All right, let's talk radar safety. If you're working with these systems, you're around some seriously powerful, invisible energy pretty much all the time. Now, understanding the dangers, well, it isn't just about passing a test. It's really about keeping yourself, your team, and your gear in one piece. So in this study guide, we're going to break it all down, turning these complex rules into simple ideas you can actually remember and use.
So here's our game plan. We'll start with the big picture. What are these invisible dangers? Then we'll get specific, looking at hazards to ordnance, fuel, and of course, people. After that, we'll cover the hands-on electrical and physical safety rules, and to wrap it all up, we'll do a quick rapid-fire review and a little quiz to make sure you've got it down cold.
So let's start with the absolute basics. A radar sends out these powerful waves of what we call radio frequency, or RF energy. The tricky part, you can't see it, you can't hear it, you can't feel it, but that invisible energy is strong enough to cause some major problems. Our whole job here is to get a handle on what those problems are and exactly how we stay safe from them.
And the official name for this whole category of problems is RADHAZ. It just stands for radiation hazard. Think of this as the big umbrella term that covers all the invisible threats we're going to talk about. Anytime you see a RADHAZ warning sign, it's telling you, hey, the RF energy here is strong enough to be dangerous. It's our first and most important keyword.
Okay, so let's get into our first type of RADHAZ, what this RF energy can do to volatile stuff. We're talking about things that can, explode or catch fire. For obvious reasons, this is where the safety rules get really serious.
First up on our list is HERO. And no, not the superhero kind. It's an acronym for Hazards of Electromagnetic Radiation to Ordnance. Just like it says on the tin, this is all about the danger that RF energy poses to things like ammunition, missiles, basically anything that's designed to go boom.
So why is this such a big deal? Well, inside Ordnance, you've got these little things called electro-explosive devices, or EEDs. They're the sensitive electrical bits that get the signal to detonate the ordnance. The danger is that a really strong RF field can actually create a current in the EED's wiring, fooling it into thinking it just got the command to fire. Bottom line, HERO is a huge deal, because radar can accidentally set off live ammunition. So how do we prevent that? Simple. We follow the book. This slide shows a table from the official publication, which is NAVSE OP 3565. Now, you don't need to memorize this whole table, but you absolutely need to know that it exists and how to use it. You just look up your radar system and it tells you the safe distance you need to keep from any ordnance. No guesswork involved.
All right, next on the list is HERF. This stands for Hazards of Electromagnetic Radiation to Fuels. It's the same idea as HERO, but now we're swapping out the explosives for another dangerous material, fuel.
With HERF, the danger isn't detonation, it's ignition. See, high-intensity RF energy can actually cause a spark to jump between two metal objects, like a fuel nozzle and a gas tank. And if there are fuel vapors in the air, which there always are during refueling, that tiny spark is all it takes to start a massive fire. This is why HERF safety procedures are so incredibly important.
So let's just put them side by side for a second to really lock this in. With HERO, you're worried about an accidental explosion. With HERF, you're worried about an accidental fire. It all comes down to detonation versus ignition. It's a simple difference, but it's a critical one.
Okay, we've talked about protecting equipment and volatile materials. Now let's talk about the most important thing we protect, people. The same RF energy that's a threat to bombs and fuel can also be really harmful to the human body, and we need to know exactly how to stay safe. And the acronym for this one is HERP, which stands for Hazards of Electromagnetic Radiation to Personnel. This is the one you really need to be paying attention to for your own safety whenever you're working near a radar that's transmitting.
So why is HERP a problem? Well, your body actually absorbs RF energy. At high enough levels, that absorption creates heat. And we're not talking about a nice warm feeling like standing in the sun. This is intense energy that can literally cook and damage your internal tissues. Your eyes are especially at risk. The core danger here is direct biological harm for being exposed to the radar beam.
And just like with HERO, our safety playbook is that NAVSE OP 3565 publication. This table is a great example. It shows the safe distances and, this is really important, the maximum exposure times for people near different radars. So the key takeaway is that safety isn't just about distance, it's also about how long you're in that RF field.
Now there's a really specific type of RH hazard called an RF burn. This one's a little different. It's not about being directly in the beam. It happens when RF energy basically turns a nearby piece of metal, like a railing or even a wrench in your hand, into an antenna.
If you touch that energized metal, the current will use your body as a path to the ground, and that causes a really nasty burn.
Okay, we have covered the invisible dangers that come beaming out of the antenna. Now, let's switch gears and talk about the very real, very tangible hazards of working directly on the equipment itself. We're talking about electricity and gravity.
You've probably seen this old cartoon Shock Hertz somewhere before. It's been used in Navy training for ages, and for good reason. It might look a little silly, but it's a very memorable reminder that the high voltages inside radar gear are no joke, and it leads us directly to the single most important rule of electrical safety.
And here it is. You need to burn this into your brain. Never, ever work alone on energized equipment. I don't care how simple the job seems. High voltage is incredibly unforgiving, and having another person there can literally be the difference between life and death.
And just having a buddy in the room isn't good enough. There are 3 absolute, non-negotiable rules for this person who we call the safety observer. Number 1, they have to be there and they have to be paying attention. Number 2, they must be CPR qualified. And number 3, they have to know exactly where the power cutoff switch is so they can kill the power in an instant if something goes wrong.
And finally, let's talk about going up the mast. The man aloft procedure is like a 2-for-1 safety special. First, it protects you from the obvious danger of falling. That's what the safety harness is for. But just as importantly, it ensures that all the antennas up there that transmit RF energy are shut down and tagged out, which protects you from all those rad-haz dangers we just talked about.
All right, we've covered a ton of information. So now let's do a quick rapid-fire review of the key terms. This is perfect for hammering these concepts into your brain right before a test. Ready? Let's go.
That's our big umbrella term. Radiation hazard. Hazard to ordnance. Think detonation. HERF, hazard to fuel. Think ignition. HERP, hazard to personnel. Think biological damage. EED, that's the electro-explosive device inside Ordnance that HERO affects. And last but not least, NAVC OP3565. That's your safety Bible, the official rulebook with all the procedures and tables.
Okay, it's time for the moment of truth. Let's see if all that information actually stuck. I'm going to throw a few questions up on the screen. See if you can answer them based on everything we just went over. This is the best way to prove to yourself that you've got this stuff down.
All right, here we go. Question 1. What does HERO stand for, and what's its main danger? Question 2. What's the name of the publication that's the authority on RF hazards? Question 3. What are the 3 absolute must-haves for a safety observer? Question 4. How is an RF burn different from a general HERP hazard? And for the final question, what is the key difference between a HERO and a HERF hazard? If you can answer those 5 questions with confidence, you are in great shape for mastering the essentials of radar safety.